Now, in 8.3, we're going to be looking at testing the differences between dependent means. That is, we're going to be looking at means where there should be a natural connection from one sample to the other, from one population to the other, where often that connection is pretty direct in terms of being the same thing on some before and after basis. And accordingly, when we're talking about these kinds of tests, instead of looking at them in terms of two discrete groups that we're making some direct comparison between, we kind of regroup and talk about it specifically as a test on the set of differences. So instead of having our single x values across each, we have d values, the difference between x1 and x2. We're making it x1 minus x2 instead of x2 minus x1 is completely arbitrary and will cause problems for some of you. Just bear that in mind. I'll try and explain it as we're going, but here we're looking at differences, and because we're looking at differences, how we order them actually makes a, oh no, difference. But anyway, that's what we're looking at there, is our differences instead of single values. From there, we talk about the standard deviation of our differences, SD, which is the square root of the sum of d minus d bar, the average distance, squared over n minus 1, which should look familiar, because that's basically the formula for the sample standard deviation S, except that's a d instead of an x, and that's a d bar instead of an x bar. I'll talk about that in a second. It should look very familiar, though. And our t-score is looking at that d bar, the mean of the sample of differences, minus mu d, the supposed population average difference, which often we're going to assume is 0 for obvious reasons, divided by a standard error term, s over root n. Did you look at that? Where in this case, we'll be running that test in terms of a t-distribution. It's going to be a t-test type of process with n minus 1, n is the number of elements in both samples, degrees of freedom. And if you want to do this kind of test, we have the same kind of process that we've had basically all the way through. I'm going to go through a p-value approach because I like p-values more, but look in the PowerPoint also critical values, and you may see a little bit of that here too, just for completeness. But anyway, if you want to follow this kind of process down, what we would do is we'd check our conditions. That is, we want to make sure things are independent and random and properly central. Then state our hypotheses and claim, along with the level of significance. From there, we have a little bit more work in terms of getting d bar, SD, and the degrees of freedom, but not too much more. Then we need the test statistic, the area for our score, in this case a t-value, and the p-value that we're going to be working from, make our decision, and follow through with our interpretation. Where in there, if we want to do a critical value approach instead, we find the critical value in the rejection regions, but we do special. And in fact, the approach here, fundamentally, is actually a t-test. Really, it's not a two-sample t-test once you get past the layer of obfuscation of having two columns of data. Because, well, we're running a t-test on the differences. It's not a two-sample t-test on the differences. It's just a one-sample test on what happens to the differences, where we're assuming that there isn't a difference in some regard, and we're trying to see whether there actually is. So when the book and the PowerPoint sort of talks about this kind of laboriously as being this thing where you got to take all your pieces all the way through and make your own standard deviation of differences and do all that extra work, no. It's a t-test. Besides all that being more work, it obfuscates the fact that that's a t-test is what we're doing. It's more meaningful to think about it that way, and it's more efficient. And at this point, you should know me well enough to know that when I can do something more efficiently and more instructively, I'm definitely going to do it that way. So, even though the book is going to present this in a slightly different manner, and you may have a little bit in the homework that talks about it and asks for a little bit more than what I would normally expect, the main thing you should understand here is that, essentially, up to some adjustments in notation and the pieces we need to find, we're doing a t-test. And that's what we're going to do for most of this section. Let's run a couple of those special, but not that special, t-test computations.